Hello everybody, this is Farah Hati. I'm using Health Economics 6th edition by Santura Noon. This is chapter 6, the demand for medical insurance. Lecture 1, insurance theory. In this lecture, you will learn about the conventional demand for health insurance, um, a summary of the empirical estimates of the demand for health insurance. I compare traditional managed care and consumer directed insurance coverages, and I talk about the regulation of managed care organization, and finally finish a brief talk about the impact of ACA on the demand for health insurance. In the previous lectures, you'll learn about the cross-country comparisons of the healthcare system, and you learn that most of the OECD countries, they have a single-payer health insurance. In comparison, United States has multiple payer insurance actually system, but the employer-sponsored insurance is the dominant type of insurance which covers 160 million non-elderly people. And then a smaller group of people, about 33 million people, they buy their own insurance individually. And then Medicare and Medicaid are the two biggest publicly insurance cover the people like elderly, disabled, and poor people. And then this Medicaid is mainly are basically pregnant women and children. Temporary, they get into the Medicaid and they get out. But the Medicare is basically anybody get into the Medicare. They're basically lifetime covered nationally. VA for veterans is the basically government-run hospital and government employees. Physician, basically insurance, which is very similar to the UK healthcare system. And then finally, you know that we have about 29 million people that don't have insurance, which accounts for 9% of the population after the ACA, and it was 16% before the ACA. By repealing it ACA, this number is going to be even above the 16%, because most of the employer-sponsored insurance and individually purchased coverage, they are reimbursed by the government currently, and by repealing ACA, they lose their tax exemption, and they cannot afford to cover the people, basically, and this number will be increased. Now, in the United States, yes, employer-related insurance are the dominant type, and a smaller percentage of the people, they buy the insurance. But the point here is that let's see how do the employers, they decide how much they have to pay for their employees, basically insurance. And they estimate that based on the total value, total product the employers they produce for them. So how do we calculate? We say that marginal revenue productivity of each worker is equal to the marginal productivity of each worker multiplied by the price of the product they can produce each year. So for example, if you produce, say that $100,000 value for your employers, then the compensation of the workers in a competitive market is based on the total value of the product you produce, and the compensation comes in the form of both wages and fringe benefits. So if you basically produce $100,000, now the employers decide basically how much they have to pay in terms of wages, how much in terms of insurance premium. So the empirical study shows that there is a trade-off between insurance premiums versus wages. For example, for a given marginal revenue of productivity of 100,000, more expensive health insurance means that lower wages. For example, if they pay you $80,000 in terms of wages, then they have to pay you $20,000 in terms of health insurance. Or if they pay you $70,000 in terms of wages, then $30,000 will be your insurance. So there is a trade-off basically between health insurance premiums versus wages. As they increase the premium, there is a decrease in the wages. The total should be equal to the marginal revenue productivity that each workers produce for each basically employers, right? So now looking at the empirical study, Miller says that there is a wage and health insurance trade-off, but in some study they see more productive workers tend to receive higher wages and increase health insurance coverage. So basically there is no trade-off. But the point here is that if they actually looking at different studies, you see that you have to cover for both observable and unobservable factors. Means that observable factors such as education, experience, and unobservable factors are motivation, dependability, intelligence. If you control for all these factors, then you see the inverse relationship between wage and the presence of employer-sponsored health insurance. Basically, Miller found that the health insurance coverage results in 10 to 11% less wages. Means that if your total compensation is $100,000, basically $10,000 to $11,000 will be assigned to health insurance coverage, and the rest of that will be your wages. Well, so what is the point of looking at this trade-off? The point here is that we wanted to know what is the demand for health insurance. So if there is a trade-off between health insurance and wages, therefore, this means that you already pay for your health insurance. There is no free health insurance from your employer's basically side. So therefore, there is no difference between demand for health insurance for individual or demand for health insurance from the employer-based insurance. So we have to basically estimate the same demand for health insurance for both of them. There are two main theories or model for demand for health insurance. One is a standard gamble model, which is more conventional and more popular. The second one is a Niemann model, which is basically, we don't cover that in this lecture. I just focus on this standard gamble model, which is more conventional, but briefly explain about this model as well. The conventional theory, which is basically a standard gamble model, says that people purchase health insurance to avoid or transfer risk because most of the people, they are risk averse, and they buy insurance to avoid high risk. So they basically they hate uncertainty. So the insurance serves as a pooling arrangement to reduce this high risk associated with aggregated loss. You get into the pooling arrangement by increasing the number of the people in the pooling arrangement, you reduce the high risk associated with aggregated loss. Now, Niemann says that the people get into the pooling arrangement because that allows the individual to receive a transfer of income from those people they are healthy. So basically, is a rightward shift in the demand curve when they're sick. So when you're sick, you get a basically income from those people that are healthy So there is a rightward shift in your demand curve when you're sick by getting into the pooling arrangement. So this Neiman says that when you're sick, basically so your utility even here is higher than from the same amount of income that you're paying for your premium when you're healthy. So, but he kind of doesn't like this conventional theory, reject this conventional theory because he believes that the conventional theory basically predict that the people behave irrationally, means that people they don't accept a fair gamble because they pay even over-insured because they don't like the uncertainty. So Neiman model says that this conventional model suggests that the people acting irrationally, because remember in economics we say that people act rationally, always make a decision up to the point marginal revenue is equal to marginal benefit is equal to marginal cost. So Neiman says that when we look at this model that people are mostly risk averse, means that the people are acting irrational and not rational, and they don't accept a fair gamble. Now, in this lecture, we only focus on the conventional theory, which is more popular. Now, the conventional theory of a standard gamble of the demand for private health insurance says that we are dealing with the imperfect information in healthcare sector. So the patients or consumers, they don't have information, and there is a symmetrical actually information between providers and consumers between. And there is an uncertainty about the time and amount of the money they have to spend. So most people are willing to pay to avoid this risk, to get into the pooling arrangement, which is associated with with a health insurance policy. So this should be A. This helps to mitigate some of the risk. So people concerned about the total expected loss, even actually more, people are more concerned about the variability of the expected loss. So they wanted to decrease this variability. So they, for example, if your income is 100,000 when you're healthy, and it is 50,000 when you're unhealthy, when you're sick, they want to actually decrease and get a basically average, that makes them feeling more secure. So let's see how we can actually estimate what would be this variability, how we can decrease this variability by getting into the pooling arrangement. So the conventional theory says that the expected value of the loss is the expected value of loss we show by mu is equal to the sum of the weighted value of the outcomes. The sum of the weighted value of the outcomes is the probability of its multiplication of the sum of the probability of the outcomes that we use as the weight by the value of each outcome. So the sum of the probability of the each outcomes multiplied by each outcomes. The variability of the expected loss is the variance is equal to the expected value of the probability by the variability of the outcomes square. Basically is the increase when the probability of extreme outcomes increases. So we look at the standard deviation, which is the square root of the variance. So we wanted to decrease this standard deviation by getting into the pooling arrangement. And I will show you by numerical example how we can do that. So don't worry if you didn't understand this fully. These are just a formula, but in the numerical example will be easier to understand. So in a conventional theory, we say that with the pooling arrangement, a standard deviation of the loose distribution declines by getting into the bigger number of the people into the pooling arrangement. We decrease this variability, and we show that numerically. The consumers gain by reducing the variability associated with the expected losses, and each person's individual loss distribution replaced with the average loss distribution of the group. So by getting into the pooling arrangement, your your loss in case of becoming sick will be smaller. So by the variability decreases as more individuals join to the pooling arrangement, and statistically we say that more symmetrical group lose distribution, and the distribution will be more bell-shaped, which is unlike the individual heavily skewed toward the right for an individual loose distribution. Now, let's go through that by a numerical example. Example 1 shows the expected value of distribution of outcomes. Suppose that there are two people, Joe and Liu, gain by entering into the pooling of losses arrangement. Suppose that, so it doesn't matter if there are two people, or say that 100 or 1,000 or more to the outcomes of this numerical example. For simplicity, we assume there are two people and they have the same probability of sickness, although independent of each other. So we assume that both Liu and Joe, there is a probability of becoming sick of 20%, and if they become sick, each of them, they lose $5 or $5,000 or $50,000, doesn't matter. For simplicity, we assume $5. And if being healthy, then 80% there is a probability being healthy, and they lose 0. Now, the standard statistic theory suggests that the expected value is the sum of the weighted value of the outcomes, means that the sum of the weighted value of the outcomes is equal to the 20% multiplied by $5 lose plus 80% of being healthy multiplied by 0 lose, which is equal to $1. So that's the standard. That's the expected value of the sum of both becoming sick and staying healthy, which is $1. Now we are going to look at the 4 possible outcomes, means that 2 outcomes for each of them. So the total of 4 possible outcomes independent of one another. So we wanted to see people might be better off by pooling of losses arrangement. So how we can decrease this variability. The probability of an extreme outcomes is lowered by pooling arrangement. For example, from 0.8 on an individual basis becomes multiplication of 0.8 multiplied by 0.8 is going to be 0.64 on a group basis, and we will show you step by step. Here, the expected value of distribution of outcomes in case 1, if Joe or Liu becomes sick, is 20% probability of becoming sick multiplied by the lose outcomes of $5, and 80% of the probability of being healthy multiplied by 0 lose. So the probability of becoming sick and being healthy should be equal to 1, right? That should be equal to 1. The expected lose for Joe or for Leo doesn't matter. They have the same probability, although independent of each other. Is the expected lose for Joe or Leo is equal to the multiplication of 20% multiplied by 5 plus 80% multiplied by 0 equal to 1, right? We showed that in the previous slide. Now, let's continue. So now we wanted to say that we wanted to measure the risk or variability of the expected lose. Not the expected lose is not enough. So the 20% probability of becoming sick multiplied by $5 lose plus 80% of being healthy multiplied by 0. Here, when we multiply this, we have to also look at the lose, look at the variability. So we look at the lose minus the expected value. So 5 minus 1 is going to be 4, 0 minus 1 is going to be 1, and then we square this column 3. So that gives us the variability, a square of the variability, and then we multiply by the square of the variability multiplied by probability in the first column, and we get 20% by 16 and 80% by 1, and then we add them up. It's going to be 4, 3.2 plus 0.8 is going to be 4, and then the standard deviation is a square root of 4, which is the standard deviation will be 2. This is a standard deviation only for 1%. We wanted to know if they get into the pooling arrangement, how much will be the standard deviation. So in the case of 4 cases, means that 2 cases for Joe and 2 cases for Leo, we have, if both Joe and Leo are healthy, then we have 80% multiplied by 80% is 62, 4%. And then if Joe is sick and Leo is healthy is 20% multiplied by 80% is 16%. And then in the third case also we have 16%. And in the fourth case, if both of them become sick, it's going to be 20%. 20% multiplied by 20% is going to be 40%. Now, here it's going to be so in the next column we have the combined loose, which is the excuse me, here the 20% multiplied 20% is 4%, and then in the column 2 we have the combined lose, means that from the previous slides we had the 0 lose in case if they are healthy, and if one of them is healthy we have $5 lose, and then if both of them are healthy, then if both of them are sick we have $10 loss here, right? Now multiplication of the first column and second column gives us the combined probability multiplied by combined lose or loss gives us 0.64% multiplied by 0, and so on. Basically, multiplication of combined probability and combined lose gives us this column. And then here we are trying to find the 1% share of lose, so we have to divide column 3 by 2 to get the 1% share of lose. So this is the, so far we have the if we get the expected total lose is going to be $2 here, and then Joe and Lou's share of expected loss is $1 here. Now, in the next slide, we look at the standard deviation. So we look at, actually we have the combined probability, we have the loss for Joe, means that one of them, and then we have the differences basically based on the loss minus the expected value of mu, and then we look at the square of the loss and we multiply the probability by the expected loss, and we get the variance here. And then this standard deviation is the square root of the variance, which is 1.41. With the pooling arrangement, the standard deviation decreased from 2 to 1.41. So you can see that this is the way the people, they decrease the variability by getting to the pooling arrangement, which reduces the standard deviation of losses and becomes more bell-shaped. So the conventional theory basically says that there are high-cost patients. If you look at the empirical studies, you see that there are certain number of the people in the United States, specifically we are talking about the United States, that they are becoming sick regularly. So individual lose function associated with medical expenses, they're heavily skewed toward the right. So in the United States in 2008 and 9, the top 5% of those regularly using the healthcare, basically are responsible for 50% of the country's medical spending, and the top 1% of the patient accounted for 22% of expenditure. The top 5% of spenders paid about like $36,000 in doctor bills, and the bottom 50% they only paid $232, which accounts for 3% of the total. So basically the top 5% they pay 50%, a bottom 50% they pay 3% of the total. Now means that we have very skewed health care expenditure. Now, the 1/5 of this top 1% of the healthcare spenders in 2008 also were in the top 1% a year later. So basically, these are the frequent users. If we identify those frequent users, we can actually help our healthcare system with these high costs. So then 9% of these frequent users use 19% of the overall cost. Anyway, this pooling arrangement reduces the variability associated with medical expenditure, basically by combining these more frequent users with the less frequent users, we can have a less variability. So now the question here is that why don't most people form their own pooling of losses arrangement rather than involve a pooling arrangement by an insurance company? What is the reason we need the insurance company so they can actually get their own pooling of losses arrangement by getting basically through their family and etc. The point here is that most people, they don't have the time or knowledge of calculating all this estimation, which basically requires marketing, actuarial forecasting, and underwriting. So the insurance company, they spend their money, they hire the experts to calculate and then offer this value to consumers by offering these services basically. Um, and also by marketing, basically they increase the size of the group, right? Um, they advertise and then basically they ask the people to join to this pooling arrangement and so basically um, uh, they pay this premium. The consumers they pay the premium because um, so coverage of the sum of or all of the medical costs by the insurance basically later on they can be covered for those mostly for that top 5% of frequent users. The actual benefit paid to a single consumers may be higher or lower than the premium received. Definitely will be lower and higher based on whether you are in the top frequent user or bottom uh, basically users. The difference between the total premium of total benefit paid out to all these subscribers should approximate a normal amount, or we can say that basically normally distributed, so they can cover their expenditure and then plus their profit, basically the health insurance. So the conventional theory is basically suggests that this pooling arrangement by an insurance company by large scale operation um, distribute the risk among the many subscribers from the high users, frequent users, and lower basically health medical care users, and then the total premium received at least compensate the total cost of paying for medical services, and then the consumers purchase this different amount and type of the health insurance coverage, of course based on their own available information about their needs for basically medical expenditure, and this reflected in the deductible, co-insurance, and number of the event covered. So the conventional theory, the reason behind the differences in coverage is the price of the obtaining health insurance, individual degree of risk aversion, and the perceived magnitude of the loss relative to the income, and then information concerning the likelihood that an illness will actually occur. So all this basically available information um, basically helps you to determine what type of health insurance you want based on your available information, of course, whether you are a top 5% frequent user and how often you want to use, based on the price of the insurance and based on the, of course, the individual degree of risk aversion. Some people they are more risk averse. Some people they are risk lovers. They don't want it to. They don't basically. They are not worried about the risk of becoming sick. So that depends on the preference of the individual as well.